Hello everyone, my name is Anthony Shivkumar, and in today's video I want to talk about the GD3000, which is a brushless motor pre-driver from NXP. Now in this video I am going to show you how I can get the pre-driver working. So there are a couple of development boards that come with the pre-driver that NXP provides. So I bought a few of them and I'm going to try to make the brushless DC motor on my drone work. Now, the reason why I'm doing this video is a couple of reasons. One is I've tried to fabricate my own board and there's always something blowing up. And so, today I wanted to, so one of the things I realized is might as well buy the development board provided by NXP and see how I can troubleshoot my design, be it hardware and software. So the GD3000 pre-driver, one of the things that they mention in this particular product is that it can be used in drones. So they have something called as the KV series quad motor control, and it uses the GD3000. So the GD3000 is nothing but a pre-driver for controlling MOSFETs. So so it can control an edge bridge MOSFET, basically edge bridge configuration. I've done a couple of videos on this before. So I won't go more into detail about it, but I want to talk about what all features and development boards they provide with this product. So one of the things that they provide is a motor control shield for DevKit, which is something that I've been working on with I have this product, but I haven't really completely made it work. They have the Freedom expansion board. Then they got the Freedom accessory board, and they have a couple of other boards. So the ones that we're going to try today, or the development board that I'm going to use today is the Freedom expansion for GD3000. So the GD3000 expansion board basically is a 3-product development board where you have the power board, you have the GD3000 board, and then you have the KV25 or the KL25 board. So it basically talks about the KL25 SPI generator, where you can connect it and connect this to the SPI generator and you can make it work. So what I have over here are these 3 boards. So this is the power board, which has the 6 MOSFETs connected to, this should be connected to the motor driver and or basically to the brushless DC motor over here. And these 2 wires will be connected to the power. So the power source that I will be using will be a 7.4 volt battery. It's a LiPo battery. So we're going to use this to basically, power this MOSFET. I have the boards over here. So this is the new one. I've recently asked them for a replacement board, primarily being because I blew up the previous one. So let's try it out. So this is the Freedom KL25. I'm just going to open the KL25 and we'll see what comes in it. They have a couple of, this is basically a quick reference manual, and it talks about the pin diagram. So I'm just going to basically put this over here. So it talks about the pin diagram. It talks about, what each pin basically means and how you can get started working with it. So we'll follow some of these instructions and and try to get it working. So here is the Freedom 25. Or the KL25. All right. So there are a couple of headers that needs to be soldered onto it so that I can solder this onto the GD3000 and then this to the power board. So we're going to get this configuration working. And we have a USB driver as well, so we can use this to basically power the board. The next product that we have over here is the GD3000 board. So let me open it and show you what's in it. So here we have it. Once again, they have a couple of stickers. It basically tells you what the Freedom boards are, nothing pertaining to the GD3000 itself. And let's open this board. And here we have the GD3000. So what I got to do is sandwich this will go on, this will be in between this board. So this would be something of this sort. So yeah, this will be sandwiched between this board, and then this will be the bottom board. So we'll try to get all of these three boards working and see if there is something wrong. The motor that I'm using will be a brushless DC motor that will be, generally you'll be connecting a propeller onto it, but I'm not going to put the propellers on it, so it might get a little dangerous. Also in this, while you get the GD3000, you also get some headers. And these headers will be soldered onto the KL25. So that's what I'll be doing shortly. And yeah. So these are the boards. So we got the KL25, the GD3000, and the power stage board. Perfect. So that's what we have over here. So what does this board do, or what can this allow me to do? So first and foremost, it allows me to test the GD3000 driver. So I can basically configure my own electronic speed controller and control my brushless DC motor. So it's a pretty expensive development board. It's $118. The whole kit might costed me around 350 Canadian dollars. That's where I am currently residing and working. So yeah, that's what it costed me. So it's not particularly cheap. I didn't want to go this route, but since I was having trouble constantly developing the board and was constantly blowing up, it was kind of necessary for me to test the chip to know what was going wrong. So yeah, there are a lot of documentations in here. So I've opened a couple of boards, a couple of the links over here. So the first thing we're going to do is open the evaluation board document over here. So I'm just going to go to the beginning of this page. So this is the GD3000 evaluation board, and this is the documentation. So what I'm going to do is I'm going to follow each and every step and make sure that I have all the necessary things and equipments or whatever be it in order for me to get started. So first and foremost, they're asking is a DC power supply, 5 volts to 48 volts with up to 10 amps. So as you can see over here, I'm going to use my battery, which is 7.4 volts. It's got 2 cells. It's a LiPo battery, and this will basically is the battery that I'll be using to power my drone anyways. So this should be the power source that falls within the range of 5 volts and 48 volts. One other thing they're talking about is a typical load, a BLDC motor. In this case, I'll be using this as my BLDC motor. I've tested it with the hobby electronic speed controller. It works, so I don't see why it shouldn't work with the GD3000. Any compatible Freedom board. So we got the KL25. So the KL25 is the compatible Freedom board that we'll be using for this particular demo. And this should be compatible with the GD3000. A USB-A male to mini or micro cable, depending on which Freedom board is used for soldering station. That's basically provided by the product of the KL25. So we have the USB cable. And last but not the least, they want a Freedom power stage evaluation board or any custom board but compatible MOSFET board. So that's what we'll be using over here. So this is the power stage board. This is all the MOSFETs that are running in here. And this should basically allow us to use this and test this whole board. So what are the system requirements? So this is the configuration of the board. So you got the GD3000. It will be connected to the Freedom board. Will be the phase A, phase B, phase C, which is going to basically do the analog to digital conversion for the back EMF. Here you're controlling the SPI, and here you're basically giving triggers to the MOSFET, the pulse width modulation, and controlling the MOSFET, controlling the MOSFET drive or the H bridge drive, which should eventually control the speed of the motor. So to describe the main blocks, so what we have over here is support greater than 1 amp peak current capacity, can operate off on a single power supply with two range from 6 volts to 58 volts with 7.4 volts transient protection, uses a bootstrap gate drive architecture. So these are the configurations and the features of this particular device. Okay, so connect to an attached 3-phase field effect transistor, jumping for configuration, test points to probe. Okay, so this is the pump select. I'm just going to leave it at default. So this is DCB to V power, phase A input select, phase B input select. So PA to PA high side PBLS. So the default is nothing but 1 and 2. So that's basically a high side to PWM4, high side to PWM5, high side to PWM3. I said B to pump in use, remove when pump is not used. Okay, so based on this configuration, so JP1 is 1 and 2. So we look over here, what we have over here. So we have one jumper here, one jumper here, one jumper here, and one, these are a few jumpers in this board over here. I'll just zoom in over here so we'll see it more clearly. Okay, and what we have over here is DCB pos to VPR, that's JP1. So the DC to V power is this one, so it's by default. This is all by default. High side to PWM3, high side to PWM4, high side to PWM5. Okay, and from select. All right, and here it says source connection, and here it basically talks about the input signals to the connection. So if you basically just sandwich them together, the connection should be kind of set for you. All right, so now we have a couple of test points. Again, more the explanation what the pins do, and this is the compatible Freedom board list. So the one that we're going to be using is the Freedom KL25. It's partially, it's got partial functionality to control the board. One of the reasons why I'm using the KL25 is because you can control it through the SPI gens. I don't have to necessarily write code. I can use a software known as the SPI gen. So we'll be using this particular software in order to control the GD3000. And here are the pin assignments. So if you just sandwich them together, you should be able to basically the connection should be automatic. All right, so here we go. So the general hardware setup, installing the software and setting up the device. Figure shows a typical setup of the Freedom GD3000 EVB. The Freedom GD3000 EVB connects to the top of any compatible Freedom board. Any Freedom power stage, a power stage board specifically designed for use with a GD3000 evaluation board, attaches to the top of the evaluation board. A power supply, typically 12 volts to 48 volts, connects to the screw terminal, J5 on the power stage board. The Freedom board connects to the PC via USB cable. A BLDC load is connected to J6 on the power stage board. The following procedures describes how to set up the hardware. solder the female headers into the top of the Freedom MCU. If SPI Gen is to be used, the Freedom KL25 must be used. Alright, so let's get that started first. So the first thing they're asking us to do is basically take these headers and solder them onto this board. So I am just going to remove some of these jumpers. So we'll have 1 year, 1 year, 1 year, and 1 year. So I am just going to sit and solder these boards right now, right here. All right. Let me try again. So you just put this, put this, put this, put this. Sometimes what you can do, let's just take a piece of paper that can help me flip it. So I have this connected. Oh, no, I made a mistake. Perfect. All right. So now I will be starting my soldering iron, getting the brushes ready. This is where my soldering is already right in front of me. I'm going to put the fume extractor on so I don't kill myself. Okay. Let's see if this is heated. Just going to check and see if this is heated. Perfect. All right. So some of the light has fallen. And Okay. Okay, so I got one thing soldered. All right. All right. Perfect. Okay. Now that it's all soldered, so the second thing that we have to do is connect the Freedom to the top of the Freedom MCU board. Okay, connect the Freedom GD3000 to the top of the Freedom MCU board. Okay, so let's do this. So here we go. So I've connected the GD3000 to the top of the board over here. So, and then connect the power stage to the GD3000 board. All right, so we'll connect the power stage board. Perfect. So now I've basically sandwiched the three boards together. So we have the KL25, we have the GD3000, and then we have the power stage board. Perfect. Within, attach a load to the face of the outputs. Okay, so I'm going to attach a load to the face of the output. So 1, 2, 3. So I'm going to dismantle these guys. Perfect. Alrighty. Connect it to one of the fees over here. Connect this to the other fees. And connect this to the other fees. So now we have the brushless DC motor connected to these guys. And with the power supply off, attach to the power input. Attach it to the power input terminal. Okay. So what I'm going to do right now is take these guys and connect this to the plus and minus. So take this, and yeah, this is the plus. So based on the battery, so the thing is, the way this is connected is the black is the plus and the red is the green. The both are exactly the same terminals, so they get swapped. So the black is the plus. So I'm going to basically tighten this guy. Put this up. Back is the plus, and we'll have here the where is the negative? Just to get my plier. Okay. It's not, it is what it is. Okay. And just gonna place this on this paper over here. It should be fine. I'm gonna clean this all up. So that I'm not pushing anything or pulling anything. And yeah, so this is the positive, will be connected because of this. Positive will be connected to the black, and the black will be positive. Yeah, the black is the negative, but because of the way the plugs are positioned, the negative over here will be the red on this wire. Okay. All right. So let's get back to the instructions. So now connect the Freedom MCU board to the PC via USB cable to use SPI Gen. To use the SPI Gen, the USB cable must be connected to the USB KL25 port on the Freedom KL25, otherwise not to program the MCU board. So let's use the SPI Gen, since we can get that working. So we might have to do some configuration. So I'm going to basically, I might have a plug already ready for me to use. Let's see. I may not have. Okay, so they provided the USB cable, so let's use it. I also have a power supply, so if we need to use 7.4 volts, we will use 7.4 volts. Sorry, if we need more than 7.4 volts rather. Okay, so I have the cable over here. Let's see what they want us to do. So we kind of have this configuration already. So we need to set it up for SPI Gen. So let's do that right now. So here we have using the FSD. The Freedom KL25 provides an ideal support platform for the Freedom GD3000 kit. In this configuration, the Freedom KL25 connects to the PC and allows the user by the GUI to control the inputs to the GD3000. However, SPI Gen can only provide limited functionality. For more advanced evaluation, microcontroller code must be used. That's fine. So let's do the basic functionality. So preparing the Freedom KL25 for use as an FSD. Okay, because the Freedom board has access to the KL25 microcontroller USB, it can be configured to serve as an FSD. Okay, let's do the Freedom board driver. Connect the standard USB-C. The board connect the standard A end of the USB-C. The board draws power to the USB while holding down the Freedom curves. Mini B end of the USB cable to the board. Downloading openSDA. Configuring them as an MCU board. Okay, the evaluation board is designed to work in conjunction with an SPI Gen example. This example is not tuned for a motor. It's simply into the user of a limited set of functionality. Okay. Okay, so what do I need to use? Preparing the Freedom for use as an FSD. Because the Freedom USB evaluation board, okay. The generic Freedom KL board does not have firmware installed. Prior to connecting to the evaluation board, install the KL25 board driver onto the PC. This causes the board to appear on the PC as a master device. It enables installing microcode by dragging and dropping to the MS. Download the openSDA firmware. Enables openSDA function for firmware downloading and debugging. Okay, install SPI Gen. Run the software. Go to NXP and download SPI Gen. Okay, so there is something that I need to download some stuff. So we'll go to the expansion board over here and motor driver. Let's see what we have here. Okay, so these are all the software that we have. The Freedom GD3000 evaluation board firmware. So when we go over here, it says install the PC as a master. It enables installing microcontroller driving. Download the open. Okay, so let's plug this in. Let me plug this in and see what happens. Okay, I can see the power of the LED on over here. So you can see the LED on over here. Yeah, so this is the power stage on, and there's also the LED in the Freedom KL25 that's on. Okay, what comes up right now is this, what it shows, the SDA info tool HM. Okay, so that's what we have over here. I do believe if we go to their let's see, what is this? Yeah, I accept. Software development package. Let me go back. I do believe that if I want to install and get into the development board, I can just go click back over here. I can just basically disconnect this and now let's see how does it work. So let me, so there's a 3-phase brushless DC motor driver. Yeah, so this is the bootloader. Okay, you know what, let me just try to redo this again. So we go over here, KVs. This is the board data sheet, Freedom board, embedded software. So this is what we have. Let's go to GD3000. Okay, so evaluation board firmware. You can use SPI Gen. So let me try to configure SPI Gen with the KL25. Install the Freedom KL25 board driver onto the PC. Discuss the board driver on the PC as a master device, enabling installing microcode by dragging and dropping to the MSD. Download the openSDA firmware onto the KL. This enables openSDA functionality supporting firmware downloading and debugging. Voice communication interface. And download the openSDA firmware. So let's do the openSDA. Installing the Freedom KL5 board driver. Okay, connect the standard A USB cable. Address power. When holding down the Freedom coalition button on the mini end of the USB cable, the small LED above the openSDA port flashes green where the board is properly connected. So yeah, now it's flashing green. If you can see over here, it's let me try to. So yeah, you can flashing kind of, slightly green over here. So I've got this basically working. and this is what it shows: tool SDA last FSL. Okay, so tools, and yeah, okay. When properly connected to the openSDA port, automatically loads the board driver. Subsequently, a master device IC and bootloader appears on the device name. Correct, we have the downloading open. Go to PE Microsystems website. Okay, I got that. So I'm just going to go to downloads. I do believe I've already downloaded the PE Micro. So here we go. And it says panel. So the PE Micro. So I need to find the KL25. Okay. Let's go to KL25. Yeah, KL25. Drag and drop to the bootloader on icon on the PC. Okay. So this is the bootloader icon. I'm going to take the KL25. There is two. This was 15 and this is KL25. So KL25. Perfect. Now that I have the KL25, unplug the USB mini and then reinsert the plug into the openSDA port. Freedom remains on and the MSC device name Freedom Clear. Okay, so now let's disconnect this and connect this. And it's now flashing red, I think. The green openSDA LED remains on and MSD name device. All right, perfect. So now we got the Freedom KL25. Perfect. Unplug the USB and it remains. So after unplugging it, it says over here, and then what I have over here is the Freedom KL25. So perfect. So now we've done this part. Installing the Freedom evaluation board. Okay, now go to the evaluation board, jumpstart to design, download these SRC USB SPI dongle. Okay, let's go to this one and download the SRC. I think we just downloaded it over here. Yeah. So, oh no, we didn't download it. So go to this and file in USB SPI dongle. Download the SREC Freedom GD3000. You know what? Let me click this link. Okay, and then let's look at the dongle. Printed circuit board, evaluation board, code generation. Okay, yeah, this is the SREC. We download this. All right, so I'm just going to basically select all, or rather I'm just going to click save pages. I'm going to put this in a file called on datasheet NXP Freedom GD3000. So it looks like I already have this. So I'm just going to GD3000. I'm just going to cancel this. I'm just going to go File, open new window. click on this. Okay, I have the SRC file over here. Okay, and what does it say? Let's keep the SRC file over here. Assume that the USB cable is connected to openSDA port. Drag and drop the SRC file and upload on the PC's mass storage to begin. Okay, so now I'm going to drag and drop this SRC file into the Freedom KL25. Okay. Perfect. Now that it's there, okay. The microcontroller installs in the Freedom KL25 board, embedded flash memory. The flashing green LED above the openSDA port indicates the download is in process. Install the green LED, start flashing and remains on. Yep, it remains on. Begin computing display, move the from KL25 port to the KL25. Okay, so now it says I got to move this to this. And yeah, you can see it's showing different colors right now, blue, and as you can see over here, blue and I don't know. All right, so let me open SPI Gen. We can come in and move this. Okay, I've done this. Perfect. All right, so now let's use the SPI Gen and let's see what happens. So let's open SPI Gen. I have SPI Gen ready over here and it looks like it's connected. So SPI dongle firmware version 5.3, it's ready. So that means it's been able to read. Run the SPI Gen program previously installed, open page. And yeah, so this is the SPI Gen, and here I have my SPI Gen. So I basically installed all the configurations that we have over here. All right, and let's try to zoom this a little bit. The GD uses SPI2 using under settings. Okay, let's go under settings. Settings uses SPI2, so type 2. Perfect. Okay. All right. Make sure the common SPI protocol is correct. It's type 2. So here we're basically saying it should be type 2. And the generic tab sends commands to the USB devices. Active when SPI Gen starts up and can be activated thereafter by clicking to expand the generic folder. To send single command to the device, click on single command under generic in the device view panel. Send batch commands to the device, click on batch commands. Okay. So let's see what we can send right now. I can GD3000 regular. I can just read. I don't know what this does. Single command. Let's send batch command. Wait for 10 seconds, batch send continuously, send once. Using this page and register tab to open the GD3000 folder and click on the register icon. Choose device set reset to yes and enable. Set reset to yes and enable to no. Set reset to yes and enable to no. Then select the I90 button. MCU automatically initializes the GD3000 driver. To write to register, select which bits to write and then click write to. Here is simply click read. Alright, let's click read. Okay. Then this is the schematic. Okay, so now how do I freaking make the motor run? Well, this is all good and dandy, but what am I supposed to do? Use the SPI gen. So we can go to bash commands and you know what, so basically what it says, so here let me try to do this. So we have all of this. I'm going to basically turn this on. And see what happens. So VLS is on. Woohoo! So we have VLS on over here. So that's perfect. Let me try to send some commands over here and see what happens. So let me just send once. I don't know what's happening, but I'm super happy. The previous board didn't even have VLS on. Okay, so set high, high, low, low, high, high. So reset, no, maybe yes. Come on, let's go to single commands. Let me see what I need over here to basically get this working. So enable must be high, I think. So batch commands, select low, set high. No, it's doing this. So yeah, if we send this once, I clear this, send once. Like it's doing the AN reset, clear interrupt, mask 0, no desaturation, set high, 0, enable. And then set high side, high side, high side. Oh. Then wait, set high side, high side, high side. Okay, all right, I get it. So this is not switching. This is not going to control a motor. All right, so far so good with this board. The green light is on, everything is on, so I am happy so far. I'll be continuing doing experiments and make this motor work. I thought they would have something that can help them make the motor work, but clearly not the case over here. But yeah, so far so good.